Hi folks, greetings of the day. My name is Sharda Prasad. Please call me SP. In this module, I am giving you a zero-level cloud computing introduction for anyone who is somehow related to IT. Right? So this would be, a fun basically, and I'll be demonstrating one motivation demo for you guys here, and stay tuned with me. Call me SP if you want to ask questions, anything. I'll be happy to answer those things. I'll give you enough time to ask questions in between or in the end of the session, in fact. And let me walk you through what we have here in this particular module. A use case, water well versus water tap. This is an analogy, normally a good analogy to understand what actually cloud computing, how you can correlate this thing to existing services which we are using basically. So to understand utility computing concept, right? So guys, cloud computing, at times we call it utility computing also. So I'll be explaining this thing, well versus water tap. Different perspectives, right? You look at your perspective, right? What kind of learning objective you have. You may be a business owner, you may be a startup founder, or you may be a developer, you may be a security expert, you may be a simple user, right? So that is what basically you would be looking at this cloud computing as a user, as a developer, as a business owner, as a security professional. So you will have different glasses to look at basically, and you can define cloud computing as per your perspectives, right? So to understand the different roles in cloud computing, so that is the reason bringing this particular topic here in this module. Then we have different stakeholders, right? So the perspective you have seen, then now you are looking at the stakeholder who all are involved there and who has got stake in cloud computing, right? So actors and their roles, basically, you may think the actors in cloud computing and what kind of role they have. To understand cloud computing architecture and characteristics, so we should know what is a stakeholder, what all stakeholders you have here in cloud computing. And then comes the motivation factor. Okay, why should we use cloud computing? Is there any saving? What is the motivation, right? So total cost of ownership, we call it TCO of your on-premises infrastructure. And if you migrate that on-premises infrastructure to cloud, what would be your saving? Or if the similar kind of infrastructure you buy in cloud, what would be your saving? How much you would be saving, right? So that motivates everybody here. So I'll be walking you through in the end that how you would be saving money if you have a server running in your own home or maybe in your own office, right? So how to save money if you buy similar kind of cloud infrastructure on any cloud service provider. Then comes your characteristic of cloud computing as per one of the standard, one of the body which basically is a leader in setting up the standards for technologies. So it is a National Institute for Standards and Technology, right? NIST. It's a US-based body, and it contributes a lot in any sort of new technology comes in. Right. So we'll stick to a few more cloud computing definition, and in the end, I hope that you would be able to write your own definition. Right. So this would be this unit 0. In fact, here it's a typo, guys, here, and this is basically here. It is unit 0 here, right? So perhaps during that course it was unit 1, right? So this is unit 0 takeaway. Students will be able to define their cloud computing career, right? So you would be right. So you can put yourself into student mode here, and you can think of your next 5 years, that what all kind of businesses, what kind of things you are going to do using this new learning, right? And do remember again, I am repeating this assignment. So after finishing this particular module, please write down that write up, and preferably you can put that write up in the comment section. I'll be happy, and I'll definitely comment back on your write-ups, your definition of cloud computing, and your career aspirations. And why I'm emphasizing on this particular course, because we have some advanced level courses, and those advanced level courses we normally are always bound to those timings, like if it is 24 hours, 32-hour or 40-hour courses, right? So normally we cannot spend much time on these very interesting things, basically. So we normally share these videos and these slides with those participants, and then they read it and they enjoy all these things. And that is one of the reason I am now sparing some time to put it on YouTube, guys. All right, so I hope our agenda is clear now here, and let me walk you through what we have here. So I think everybody is familiar with Gmail, and this is a mailing service by Google, and it's an amazing product. I also love this particular project, and that's why I've taken this as an use case here, right? So we can look at this Gmail as an user. Then if you are a developer, you can look at Gmail as a developer, and if you are a business owner, you can look at Gmail as a business owner, right? And then you would see that what actually Gmail is. If it is a simple user, what that user would say, that Gmail is a simple mailing service, right? You receive mail and you write mail and you save your mails there and all. If a developer is there, then they'll say Gmail is a distributed mailing system. It has got n-tier architecture. There are a lot of database servers, a lot of the servers in between. Then you have a messaging tier, then you have a load balancer, you have a data center, you have thousands of server running and doing a lot of high availability kind of thing, backup, recovery, fault tolerance, and number of things, right? And business owner, they will say that how much money basically they are investing, and then how much they are saving, right? So that would be the perspective they will see. If they have a company where they have thousands of users, right, and they want to have their own mailing kind of solution in, so they'll see that if they buy Gmail, what would be their saving if they create a similar Gmail kind of mailing system in on their own infrastructure, what would be the costing and all, right? So these are the different perspective, guys, you will look at, and I hope the out of these three perspective, you guys will you folks will fit into one. There may be many the users, many of you are developer or DevOps guys, and many of you would be a business owner, maybe a pre-sales guy, or maybe looking some accounts for many different kind of portfolios and all. 1 million users. So during its earnings call some time back, Google announced that Gmail has more than 1 million monthly active users. Guys, this slide is very old, in fact, and perhaps at today, definitely it would be more than 1 million, but it's 5-6-year-old slide. So that time they were having million monthly active users. So you can imagine that the kind of traffic they were managing, right? And this is a simple architecture, guys. So you can think of a client sitting here, a user as an user, you are sitting here. This is the user here. And then you have your the client system running on your machine, right? So it may be your mobile phone, or it may be your desktop. So your Gmail browser based client system is running there, And with the help of that client, you are interacting with your Gmail. And what is Gmail, right? This is the front end part of Gmail. And then there are many other ends or tiers basically. So somewhere your data, your mails, your files, attachments are being stored. So that goes to your database. And then who is basically doing all those things? Who is handling your identity that this mail is coming from this particular user, and no one else should look at the messages, mails of this particular user? Who is giving that kind of isolation and all, right? So there are in between many services, right? So for that matter, you may have a simple login.html file, right? Through that you get into your backend, right? And that backend would be your server is running there, maybe some the object, some services, or servlet if it is a Java kind of application. So you may have a servlet which is handling the communication between that client and this particular web server. Then from that web server, in fact, there would be a lot of in between layers out here. Load balancer, you may have your many the firewall kind of thing here, which will be filtering the spam kind of requests to their database servers and database your mailing web server and mailing databases and mailing application tearing with. And after this web tier, then comes your application tier, and then a lot of messaging tier in between, and then database tier. And how these databases are made highly available, and also they are distributed across different data centers, and there is a kind of redundancy. Parallelly, n number of resources are available there. If one resource goes down, other is always there. So user will never come to know that there is a outage at the back end, right? So that is all abstracted from you, and you feel that Gmail never goes down, right? And that is what the service provider would be basically aspiring for, that their user should never know that there was any sort of outage. So how many server does Google have actually, right? So have Google watchers been overestimating the number of servers in the company's data center network? Recent guess times have placed Google's server count at more than 1 million, right? So that's again a kind of a story. And again, long back, you will go and verify these things and look at that how many server Google is using for Gmail particularly. So but new data on Google's energy use suggests that the company is probably running about 9 lakh servers, right? So this is huge. Actually, it's almost a million, right? So you can look at these figures here. Perhaps you will have more now. Google, they are managing the hexabytes of data, right? And definitely they would have millions of servers in fact. With few features of Gmail, if you are not aware, you can go and look at these features in fact. And there is a feature called Smart Reply in Google's inbox. And through this Smart Reply, inbox can now respond to emails for you automatically, right? So this auto response, right? So now if you are a user, maybe after 18, 19 or 20, if you are a very new user to Gmail, probably this would be the kind of feature which you already had in the beginning. But I'm using Gmail from the beginning actually, and I know that how Gmail is progressing basically. My impression when the first Gmail launched, I was fond of Hotmail in fact, and then started comparing Hotmail and Gmail. So back in 2006, if you go, right, so there was no comparison at all with the Hotmail and Gmail. Hotmail was superb at that time, but now you can see that Hotmail and Gmail, they are competing like anything in fact. It's difficult to say that which one is better and which one is not better. There is a great feature, Gmail Labs. You can look at that whether they are continuing with this feature. So some crazy experimental step Google put on Gmail Labs, right? It is a testing ground for experimental features that are not quite ready for prime time, right? So they are not the feature which are production kind of. It's just a beta kind of thing, and they put it in, and they use their own users to test, and then if that feature is a great success, so they can bring it to the prime feature category. They may change, break, or disappear at any time, right? So that's why this Gmail lab, you can go and look at the Gmail kind of thing in your Gmail console. Then comes, guys, when we are talking about cloud computing, so the stakeholders, right? So who all are there responsible, and what is their responsibility if it is cloud computing, right? So roles, activities, and components. As per the roles, you can divide this stakeholders as per their activities, and as per the components they use, you can divide your stakeholders, right? So the most important stakeholder of cloud computing providers, or we at times call them cloud service providers, CSP, right? Person, organization, or entity responsible for making a service available to cloud consumers, right? Amazon, AWS, Microsoft Azure, and Google's GCP, right? So they are the cloud service provider, and there are many more in fact. Who are the consumers, guys? Person or organization that maintains a business relationship with and uses services from cloud providers, right? So Gmail users, you may have like a GU employees, students. So luckily this is the slide. At times, I think it was at Graphic Era University, I was delivering some lecture, right? So that was mean for the Graphic Era, right? So it's a Graphic Era is again a kind of the consumer, right? And it's an organization level, and it's a big consumer. So similarly, you may have your own organization, like TCL, Tata Chemicals. So that was another client I was handling at that time. So Tata Chemical users and all, right? So these are the kind of consumers you can think of, right? Big consumers, small consumers. Then comes the broker, an entity that manages the huge performance and delivery of cloud services and negotiates relationship between cloud provider and cloud consumers. Cloud Sharepass acquired by Accenture, and there are many brokers actually. And this Sharepass, they did a phenomenal job, and they eventually acquired by big company Accenture, right? And you can look at the Sharepass portfolio and what kind of job they were. That is what cloud broker. And you can think of it, if that interests you, you can think of that brokering kind of a career in fact in cloud computing. And then comes auditors, a party that can conduct independent assessment of cloud services, information system operations, performance, and security of the cloud implementations. Cloud audit, its development code name was A6, Automated Audit Assertion, Assessment, and Assurance API, right? So you can look at this cloud audit, right? In short, A6, what all responsibilities has. So similarly, you can find out a kind of a business prospects, or the career prospect, or maybe research prospect in this particular role. And then finally, careers, the intermediary that provides connectivity and transport of cloud services from cloud provider to cloud consumer. We may term them as the carrier, right? Huawei, right? So it's one of the leader, and now they are, Huawei also is coming to the cloud service providers category. And but you can look at that, what kind of thing Huawei is giving you, and that is what the career basically you can think of. Right. So from this diagram, the cloud carrier is sitting underneath, and on top of that you have your cloud consumer users. They would require those carriers. Even as a cloud auditor, you would require carrier. As a cloud service provider, you need, it's a bigger role in fact, and you have many things underneath that. On the top of cloud carrier again, and the brokers, and you have different kind of brokerage services out there, and it's again on top of the carrier, right? So that carrier is important, and this carrier you can think of like, say, we have copper, now we have fiber, right? And these the carriers are managed by in between a lot of ISPs and all, and there are people who are managing those ISPs and all, right? Or is there any alternative, right? So there is an alternative, and recently we've seen that the Elon Musk, they are going to launch that the satellite links, and through that satellite link, if you get your cloud services, right? So that will fall into that particular category as well, right? Or some other sort of carrier, if you are aware of, like oceanic cables and also, right? So there may be, many disruption in this particular stakeholding as well, guys. So the consumer, auditor, providers, broker, and the carrier, and many more stakeholders you can think of: reseller, aggregator, preferred channel partners, right? So you can think of all these things, guys, and you may have a lot of research, business, or career prospects. Adopters or software service vendors, you can think of this, like TCL migrates to Google Gmail. So that is what I am taking this. This is a long back slide, in fact. I guess in that year, early year 2014, 15, 16, I guess, that Tata Chemical, they were migrating from Outlook to Gmail, I guess, right? So Gmail, that's a totally cloud product, right? So then, the how to switch from, those desktop-based email system to cloud-based email system, right? Similarly, in graphic era, that time it was a kind of a migration from Office, their Outlook to Office 365. That is basically the Microsoft cloud email service. Cloud tool providers, TCPs we call. Red Hat is a leader in providing open source computing solution for enterprise and end users, Cisco, Veritas, right? So now see that Red Hat is now the part of IBM, right? So IBM, Red Hat. So Red Hat is a leader in their own things, right? And Bitnami cloud tools, right? Bitnami, if it comes to, the particularly the CDN and all, the content delivery network and also Bitnami, these kind of giants, they are very, very, specialized in their own kind of domain, right? So, and many more you can think of, basically. So taxonomy of cloud computing. Cloud services claim to provide nearly everything you need without requiring you to run your own IT infrastructure, okay? Right. So guys, here it comes that the very first slide I was talking about, that the water well versus your the tap at your own houses, guys. So look at that analogy here. If you have seen your old houses, you've been to your parental houses and all. So there used to be every house will have a water well, basically, and you need to maintain it. You need to, every day you have to pull the water, right, to cover it, a lot of maintenance things and all. But it was under your control. You own it, basically, right? So you can think of now, we cannot own that kind of infrastructure now if you are living somewhere in metros and all. So we cannot think of it, right? So however, we are used to now water tap. Every household, you see that you get water, you get clean water, you get your the bill, that how much water you have consumed in a particular month, right? So what basically you are paying what you have used basically, and that's why I've used that particular analogy here, right? So cloud computing, you can think of IT resources in as in your legacy IT resources as in your water well, and now cloud computing IT resources, they are basically the IT resources as an utility. You, whatever you need, you pay for that, right? If you don't need something, you don't pay for it, right? So, and it would be very, very inexpensive, and that's why after cloud computing in early 2000, in fact, if you see that there are a lot of disruption, many new startups and people, they've started doing phenomenal things, in fact. Right. So this line makes sense out here. Cloud services claim to provide nearly everything you need without requiring you to run your own IT infrastructure. IT means, guys, here primarily your compute, storage, and networking, right? And all the related support things with those three things. The popular science assumption is that cloud services live in the cloud and thus are free from the boundaries the rest of us face. This simply isn't true. Without internet, cloud computing is not possible, right? You can think of that. A lot of discussions are happening nowadays that without internet also you can think of cloud computing. But here assume that without internet, you are not going to get those IT resources at your place. Cloud services, like all other IT services, originate from a data center or data centers located in a specific geography. And this means that both the service and you as the consumer are still bound to the laws and regulation of your respective jurisdiction when conducting businesses, right? So this is the key, guys, right? So when you have your service provider, and that service provider is sitting somewhere in a different law or different jurisdictions, and as a consumer you are sitting somewhere in a different jurisdiction, right? So then how the law is, how the governing the jurisdiction comes in picture, that is again a big area to explore, and many of you can think of career research and business in this particular field domain as well. This is a simple diagram, and you can just think of the root of that diagram is basically the role base things which we've talked about, like 5 roles, the stakeholders, basically, the service providers, the consumers, brokers, auditors, and carriers. And then on top of that, you have activities performed by those roles, right? So for that matter, provider, cloud service provider, what all activities that provider performs: security, privacy, cloud service management, service orchestration, service deployment. These are the roles, these are the activities they performed by these roles. And then on top of those activities, there are components which are used by those stakeholders to perform those activities. Like if it is service deployment, so you may have the how to deploy your services. It is deployed publicly, privately, or in a community kind of infrastructure, or it's in a hybrid kind of deployment infrastructure, right? Or you may have the resource abstraction and the control layer, physical resource layer. So these are the different components which will help you uh, to deploy your things. Similarly, if you are talking about the cloud services management activities, on top of that we have portability, interoperability, provisioning, configuration, and business operation. These are the components. And if we look at provisioning or configuration, right? So you may have monitoring and reporting, metering, SLA management, and all. So these are the things, like when we talk about the DevOps kind of practices and all. So we have, you know, the subcomponent level, and that is the modularity basically, right? So you may have an independent module which is handling the resource changes, which is handling those monitoring and reporting kind of things, like we'd be talking about some monitoring tool, or maybe a logging and all these kind of. So this is how this whole tree you can understand, right? So the base is the role, and then activities provided, and then the component used in those activities, and then sub component related to those big components, right? So, and those sub components, you can think of the services available in any cloud service providers platform. So I'll be diving deep into a few of these sub components as well here. I can take one branch of this whole tree, a taxonomy of cloud service provider, guys, and you can look at the cloud service provider. Here we would be focusing more into AWS as a cloud service provider, and then the cloud service management activities at this level 2, and then the provisioning and configuration, that is the component at level 3, and then the metering, your billing and all that is it. So billing component, billing sub component rather, I'll say, right? It takes care of that, your usage of your all services, basically how much compute, how much storage, how much network kind of services you have used. Accordingly you are billed, and then you pay accordingly, right? SLA management and all. So this is to make it very, very simple, and you can look at this particular branch of that taxonomy. And this is the Forrester's one of the slide. I think I'm referring to that. Tech Radar for Infrastructure and Operations Professional, Cloud Computing, Quarter 2009, a taxonomy of cloud computing. And it is relevant, guys, when we start learning cloud computing. So you will say that there is something called IT infrastructure. So IT infrastructure, which is sitting on top of your physical data center, it's basically your the big server, big storage infrastructure, big network infrastructure, right? So that thing is still there, and we will call it infrastructure as a service, right? So on top of that sits a layer of abstraction, right? Like storage as a service, cloud labs, disaster recovery as a service, desktop as a service, right? And then you get a further level of abstraction, and we call it platform as a service, right? And then on top of that platform as a service, you can put many further level of abstraction, and we're calling them database as a service, right? So business processes as a service, cloud billing as a service, integration as a service, and so on, right? So that simply you can say SaaS, software as a service. So we'll be talking about everything as a service here now, because we are at that level now, in fact. So this diagram is still valid, and you can always build your things on top of this diagram. And now it's time to define the cloud computing. What NIST says, cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources, right? So configurable computing resources, guys, whenever it comes here. So CSN, always remember, C is compute, S is storage, and N is network and related thing. So network, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service providers interaction, right? So you go to your water tap analogy, right? If you want water, you will open it, you get, and when you are moving out of your house, you are not opening your tap. So there is no consumption of water, and you would not be paying any bill because you have not consumed any water, in fact. And same thing happens there in the cloud computing. If because there is a pipeline basically, and that is the carrier, in fact, right? And similar to your water pipeline, it's coming, right? So if you have your network pipeline coming to your premises, and if you are not using anything, right? So you may be paying some nominal for that pipeline. Maybe if you have that kind of, if you have on demand kind of prepaid kind of things, or you have some sort of plan, so definitely you would not be paying for those things as well, right? So what you would use, you would be paying for that. And this is what a simple NIST, right? So the 5 characteristics basically, guys, you can think of the cloud resource, cloud computing resources. That is the very first characteristic is all those IT resources are on demand, right? Second characteristic is they are basically shared resources, right? So shared pool of configurable resources. You get your resources which are shared, and they are rapidly elastic, rapidly provisioned and released. So rapidly elastic, right? And there is no intervention from your provider, and they are measured, they are metered, and they are offered to you through the broad internet access, right? So network access on demand, shared resource pool, rapidly elastic, and metered, right? So these are the things, basically 5 characteristic of cloud computing you can think of, right? So let us just summarize it further, and this is what Gartner writes: a style of computing in which scalable and elastic IT-enabled capabilities are delivered as a service to external customer using internet technology, right? So much simpler, in fact. And further, Forrester defines cloud computing as a standardized IT capability delivered via internet technology in a pay-per-use self-service basis, right? So this the way we also understand cloud computing, right? We will try to define our own cloud, right? So try to define your own cloud, and don't forget that the well, that the your domestic home water well versus water tap, right? And you will understand it better. Then comes a great motivation: the total cost of ownership of your on-prem IT, right? Again, I am taking that to water well versus your water tap, right? So when you want, you don't want to get that water pipeline, right? You want to be very independent, so you dig your water well, and then see, you would require at least maybe 100 square meters or more than that, right? And then you have to dig it, then you have to provision things and all the infrastructure, and then you will have to keep one caretaker there. There are people, they would be every day, they would be fetching water for you, right? Pulling it up and down, right? Pushing it down, then cleaning, and then closing, and then the compliance, and then getting permission from government, and then many things, in fact, right? So what it, you can imagine the cost you have, right? And if you are a single member there for a day, and maybe at times in summer you have good family members there, but most of the time there are only, you have your caretaker living there, right? So that is an liability kind of thing, guys, for that water well, right? So what you would have saved a lot of money if you have opted for the water pipeline. The similar kind of thing you have, right? When should you go for cloud infrastructure, and when should you when you should provision your own data centers or own your own IT infrastructure? So a holistic perspective of CTO, incorporating both the quantitative and qualitative factors uniquely pertinent to comparing the benefits and risk of an on-premises IT solutions, guys. Right. So when we talk about now the IT solutions, IT means here, guys, primarily your CSN, compute, storage, and the networking relating to compute and storage. Right. So how that compute, storage, and network resources, how you are going to get Either you should have those things on premises or you should get it from the cloud. If you get it from the cloud, what is the motivation? Are you saving a lot of money, or is it secure? So all these things you would be basically looking at. And let us look at this thing. This is again another tree, guys, here. So the TCO, you can segregate your TCO into two branches here. Quantitative, the factors are those that can easily be associated with a monetary cost, right? So that's why it's quantitative. However, there are many factors which are not quantitative, right? So we will call them qualitative. The factors that do not directly or easily translate to an amount, dollars or rupees or maybe any other currency, but are of equal importance in the decision making process because they address strategic value and issues or impact intangible or overall institutional cost, right? So that may not be directly translated to the cost directly, but it it affects your the kind of business service and offerings, right? So quality, and most of the time that are your customers happy? That is how, when your customer would be happy, it's not only that customer wants the less expensive the services. At times customer, they don't mind paying anything if they get quality services, right? So that is what, right? So here the TCO, you will have to look at that. What is the qualitative and what is the quantitative, uh, the things, the factors, right? So let us quickly divide those quantitative things further, right? So you may have a quantitative thing like hidden subsidies and indirect cost, one time and ongoing, right? So that is like if you have water well and water tap at your, right? So if you already had a water well and you want to migrate to tap, right? So then perhaps you will have to apply for a connection, and maybe that connection cost you, or then every month maybe there is a fixed charges and all, right? So these are the direct cost basically, guys. Similarly in IT infrastructure, if you are managing your own data center and you don't want to send anything outside your infrastructure, so perhaps you would not require the internet there, which is very unlikely at this moment, but you can think of that, right? So in that such kind of scenario, right, so you will have to go and buy some the connection, right? So those connection may be from different ISPs, and also there you it depends that what kind of bandwidth you have got. It's a lease line kind of thing, or it's basically a copper, or it's basically satellite link, or it's fiber, right? So it depends, right? So facility cost, indirect cost, grants, student labor, disaster recovery system, readiness, business continuity response, right? So these are the things which comes to hidden subsidies and indirect costs, right? So which again, they are coming under quantitative thing, but they are hidden. There are some one-time costs, right? Like integration, migration cost, right? So one time, like for example, that you have your data center on premises. Now you want to get away from that data center. You were paying some rent to that data center. Now you have removed your infrastructure from that data center to some cloud, right? So then you would not be paying for that the facility, right? But you'd be paying something there to your cloud service provider, right? So that would be, one-time cost, and you can see a lot of heads out there, and there would be ongoing cost also, right? So ongoing costs, there are every month you would be given a bill kind of thing, right? So there are some minimal subscription cost for many services, and there are options that you would always have that there is not a kind of subscription kind of a cost, right? So many cloud service provider, they have things. If you are not using them, you are not paying at all anything, in fact, So we'll be looking at those kind of thing in the future modules, guys. And guys, look at this qualitative things. Agility, that is, you don't see it happening right directly, but it costs a lot. Contract review and negotiations. So again, you cannot translate these things to direct dollars or rupees. Elasticity and scalability, right? How flexible your infrastructure is. Right, the if you need one server at this moment and maybe thousands of server next moment, right? So is your on-premises infrastructure capable of doing that thing? No, not at all. And that is one of the advantages moving to cloud, and you get that rapid elasticity. Regulatory and policy requirements you can easily implement. The security are much better when you move to cloud. So that is what the initially people, they had a lot of apprehensions about the security when they think of moving or migrating to cloud. But gradually people, they've realized that their data is more secure on any of the cloud than putting that data on premises, service levels and all. So this is the kind of the total cost of ownership of your IT resources on premises, and then how you would be paying when you migrate to cloud. Some examples. So I would give you a quick demo here, guys. And AWS total cost of ownership, cloud storage nearline TCO pricing, that is Google, and total cost of ownership of Azure. Right? So I'll just give you this demo here and look at, this is what AWS, they are the leader basically continuously for the last, nobody has overtaken them as far as the infrastructure cost is concerned. And the way they are innovating, so it appears that the competition, there is no competition at all, right? And I would be taking the AWS cloud infrastructure TCO first, guys, and you can look at your preferred CSPs there, and there may be not only these three, there may be many more in fact. So see here, I'll just give you an example. Right, so let us say you are maintaining a mail server on premises, right? So if it is a mail server, and how much it cost you on premise, you know that you have bought a big server and that server was costing you around 2-3 lakhs, and then you have a backup infrastructure storage, then you have a network infrastructure, and then you have a space, then you have cooling, power, then security and all, right? So minimal, if you calculate it, so the infrastructure itself would be costing you lakhs of rupees, maybe 10-12 lakhs. And then the recurring every month electricity bill, you have your employee, you have an admin, you have a security guy, then rental of that particular location and all, right? So it comes easily, maybe if not less, the crores of rupees in a year, or maybe at least lakhs of rupees in a year you can think of. So let us see the similar kind of thing. However, you have a small mailing server running on that particular server, right? So we have a server facility offering in AWS, and that is, we call basically Amazon Elastic Cloud, Elastic Compute Cloud, right? So this is basically the abstraction of your server on premises. And let us see that how you would be, what you would be paying if the similar kind of thing you do in your AWS infrastructure, right? So I'll use this quick estimate, and I'll simply write here, this is the thing. Let me write down here. This is cloud for ML, right? Guys, this is an introductory 0-level module for our advanced course, that is cloud for machine learning, right? And now you have to decide that which data center you want to put your that particular server, right? So you can select those data center regions. So you have different region, like around more than 25 regions are available there. So as per your the legal, if there are many legal issues in that, you will always select the region which is under your jurisdiction. So if I am in India, let's say I select my Indian data center, and that is in Mumbai as of now. We have a new data center for AWS coming up in Hyderabad, but it is not yet generally available, right? So I'll select Mumbai, and let us see how much it costs us to host a simple server which will maintain my mailing workload, right? So quick estimate. So I don't want to get into, let us, I was using Exchange, or it was running on Windows definitely. So Windows server, and let us go to Windows server, right? And I want to put it in a, it runs very, the compute is hardly 0%, 0.001% of my compute and storage being used, but we need it, so we are using it, right? So let us say we need one CPU, and we need 2 GB of RAM, and now you can select that T3 small, or you can go beyond this also, right? So you can add the requirement, further more requirements, and you can search the instance type. So let me go beyond this, and I'll go for the T3 nano, right? So this T3 nano is the minimum, and that can give you, right? So 2 virtual CPU guys, and half GB of RAM, right? And that gives us a great kind of uh, um, workload support, right? And let us go to CV. You can try all these things. So I am showing you that if you go reservation term, and if you pay it full upfront, right, guys, you will get a lot of saving basically. And let us, I want only 5 GB of storage, right? A very minimum kind of thing I have, but I wanted to have that thing. So now guys, see here, the motivation for you is that the costing for your server monthly is zero, right? You are running your things on Windows server, right? So you are paying zero for that. What you are paying for is just storage, and that is around $0.50 in a month, right? And $0.50 totally, and what, for 3 years you'd be paying 176 US dollar, right? So this is the kind of peanut for. So anybody can think, and you should be wondering now that why I'm paying. You may be paying at least 5,000-6,000 monthly, right, for your simple mail server which is maintained in your office or at your home, right? So you can easily think of migrating those kind of workload to AWS with this minimal zero cost, in fact, right? So, and you can look at many things. So this is the quick kind of demo which I could afford in this limited time, guys, for you, and you can think. And we are looking for you to enroll for our other modules, guys, and we would be definitely exploring things further there, right? And this is what I have here in this TCO, total cost of ownership. And similarly, you can estimate, you can add another services like storage, right? So there are many storage services available here, right? So say you want a big storage for your backup kind of infrastructure, right? So S3 is that. You will have a lot of saving there again, right? So almost you will go from, hundreds, thousands of rupees every day or monthly. If you are paying on premises storage, it would be translated to zero in AWS, right? And similarly for other type of services you can think of, right? So this is what I have here in this particular demo, right? And I guess my screen was not visible there, right? So now you can see my screen here, and right. So this is what the screen, guys. So I have demonstrated the estimate of this, and you will get into this kind of thing here, and now this is how it looks. You will add a service, and this is EC2. Configure your EC2. Put your some name, let's say demo here, and come here, Linux machine. If I go, I'll select my own, and I select a very nominal infrastructure. Let's say I select T3 Nano, right? And quantity, let's say 1 I have, and I paid all upfront for 3 years, right? And I need 2 GB of storage space. And look at this thing, guys. For 3 year, $55 you'd be paying, right? And this is peanut for you, right? So you can save a lot of money out here. And that's it from this TCO calculator, guys, I have. And let me take you to my slides there. Here we are, right? So that is the total cost of ownership. And in the end, the wrap up. So the data is king. So data for education, energy, banking, insurance. So we have different sort of data, and we work on data, and we analyze it, and then we get great insights. We do a lot of stuff, interesting stuff, right? So and user for who are the user of that data, right? So educational users, there are people who are into education research, educational business, educational learning and all. So they are the users. Similarly for energy, banking and all, we can think of cloud service provider, broker, auditors, and carriers for education, energy, insurance, right? So you can think of the as in service educational service provider. You can think of a brokerage service provider and all, right? So what basically you have different segment of data. That data goes to your cloud computing infrastructure, and then your users, they access it. Your user get good services, they save a lot of money. You do good business, you also save a lot of money, and everybody is happy. So it's a win-win for all, and it's a great motivation to migrate. If you are still using your on-prem things, keep on using your existing infrastructure and put your new workload on cloud, any cloud you can think of, and you would be happy. You would be making your customers happy. You would be saving a lot of money there. See you in the next class, and these are the few resources I'll be putting in on below the this video. My name is Sharda Prasad. If you liked it, please recommend this video to your friend, families, your colleagues, and do comment there and share it and subscribe it. So thank you and good day.